So here's a noticeably complicated equation. But they all have a 3x in it. 3 to the x, 3 to the x, 3 to the x. That means you can factor it out. Now it's less scary because you just ignore that 3 to the x for a minute and you have a regular quadratic that you're trying to factor. So multiply the 6 to the 3, you get 18. What multiplies by 18? Negative 18 adds be negative 7. That's negative 9, positive 2. But we got to do, since we multiply by the 6, we divide by the 6. Nine over 6 reduces to 3 halves. So the 3 halves. And then you move bottoms up. 2x minus 3. Reduce that to 1/3. And move the bottoms up. 3x plus 1. So we've got it factored equal to 0, so you set each factor equal to 0. Or just tee it up. So you first look at 3 to the x equals 0. There's nothing you can raise 3 to as a power to get 0. That never happens because there's a horizontal asymptote when you think about the graph. Never equals 0. 2x minus 3 equals 0. Solve that. You get x equals 3 divided by 2. And 3x plus 1 equals 0. Move the 1. You get negative 1. Divide by 3. It's negative 1/3. So 3 halves and negative 1/3. So very similar to what we just did in the last problem. They both have an e to the x. We could factor that out. That's x cubed minus 16. X. So now there's an x in common. We could take that out also. So that's x squared minus 16. Tee it up. E to the x will never equal 0 because of the horizontal asymptote, just like on the last problem. If you set x equal to 0, you get x equals 0. And if you set x squared minus 16 equal to 0, you could have also factored it further. But you get x squared equals 16, which means x equals plus or minus 4. We have x equals plus or minus 4 and x equals 0.